welcome back to my office hours. In this video, we will learn the differences and links between atmospheric pressure, gauge pressure, and vacuum pressure. Pressure is defined as the magnitude of force exerted per unit of area, in the limit as this area shrinks to zero. This definition addresses the fact that pressure may vary in space in a flowing fluid. There are three different categories of units for pressure. 1. Force per area. For example, Newton per square meter, which is also known as Pascal. 1 kilopascal denotes 1,000 pascals. Similarly, pound force per square inch, also known as PSI, is often used in countries adopting the imperial unit system. In these countries, pound force per square foot, or PSF, can also be found in use. 2. Liquid column height. According to hydrostatic theories, pressure measurement can be associated with an equivalent height of a column of fluid. For example, when measuring our blood pressure, the readings use the unit of millimeter column height of mercury. In this situation, mercury is the standard liquid used for the pressure measurement. 1 millimeter column height of mercury is equivalent to 133.32 pascals. 3. Standard atmospheric pressure. The standard atmospheric pressure is defined as the atmospheric pressure measured at the sea level at the standard atmospheric condition of 15 degrees Celsius. 1 standard atmosphere, symboled as ATM, is a unit of pressure defined as 101,325 pascals. The ATM unit is roughly equivalent to the mean sea level atmospheric pressure on Earth. In other words, the Earth's atmospheric pressure at sea level is approximately 1 atm. Now that we have some basic understanding of pressure and its units, let's first talk about local atmospheric pressure. The atmosphere on Earth is held in place by gravitational force. In an air column model, if we can measure the weight of air in a column from the ground surface to the outer space, and if we divide this weight by the area of the ground surface the force acts on, we will derive a pressure caused by the atmosphere. This pressure is called the local atmospheric pressure. Because of the variations in altitude and temperature at different locations, the local atmospheric pressure often varies. For example, the local atmospheric pressure in Los Angeles is approximately 101 kilopascals, whereas the local atmospheric pressure at the summit of Mt. Everest is only 35.6 kilopascals. In fluid mechanics and many other engineering fields, three types of pressure are often measured and used in various applications. First, the absolute pressure. The absolute pressure is measured relative to an absolute zero pressure or a perfect vacuum. For example, the outer space can be viewed as having an absolute zero pressure. Because local atmospheric pressure is measured relative to the pressure in the outer space, when we say that the local atmospheric pressure at the summit of Mt. Everest is 35.6 kilopascals, we are referring to its absolute pressure value. Second, the gauge pressure. The gauge pressure is measured relative to the prevailing local atmospheric pressure. When measuring the water pressure in a pipe using a pressure gauge, the reading given by the pressure gauge is the gauge pressure, as it is a reflection of the difference between the absolute pressure of the pipe flow acting on the inside of the pipe and the local atmospheric pressure acting on the outside of the pipe. If the pressure gauge reads 5 psi and the local atmospheric pressure is 14.7 psi, then the absolute pressure can be calculated as the sum of the gauge pressure and the atmospheric pressure. That is, 19.7 psi. Notably, the gauge pressure value of the local atmospheric pressure is 0. Third, the vacuum pressure. In situations where the absolute pressure is smaller than the local atmospheric pressure, such as inside a vacuum cleaner's vacuum chamber, the gauge pressure calculated will be negative. This negative gauge pressure is also known as a positive vacuum pressure. As we define vacuum pressure, it is the difference between the absolute pressure and the atmospheric pressure when the latter one is larger. Use this figure here to understand the relationships and differences between the pressure 0, local atmospheric pressure, absolute pressure, gauge pressure, and vacuum pressure. What are the advantages of measuring absolute pressure versus gauge pressure? Since all the facilities in a refinery or manufacturing plant share the same elevation and atmospheric pressure, measuring gauge pressure is accurate enough for most processes. However, specialized situations call for absolute pressure, which are independent of fluctuations in atmospheric pressure. Absolute pressure gauges, which have an internal vacuum chamber that is used as a reference for making pressure measurements, are found in numerous applications, including altimeters for aviation, monitors for liquid vapor pressure, distillation processes, HVAC, and semiconductor manufacturing. The pressure of dangerous arsine and phosphine gases used in the semiconductor manufacturing process must be carefully monitored during storage and transport. Because atmospheric conditions fluctuate, it's important when monitoring dangerous gases to use a reference point that does not change. Thank you for tuning into this video. If you have any questions or specific civil engineering topics you'd like me to cover in future videos, feel free to leave a comment below. Your likes and subscriptions motivate me to create more content, ensuring you don't miss out on future updates.